Hi everyone, welcome to the class. Today we're going to discuss paper 1 practice exam for IB Mathematics Analysis and Approaches Higher Level. Question number 1. On his way to school, Suresh stops for coffee with probability 0.8. If he stops for coffee, the probability that he is late for school is 0.4. Otherwise, the probability that he is late is 0.1. Given that on a particular day, Suresh is late for school, what is the probability that he did not stop for coffee? Maximum marks for this question is 5 marks. Let's get started. First, try to understand what are the things given in the question. Okay. Here, they clearly mention that Suresh stops for coffee with probability 0.8. It means that the probability he stops for coffee on his way to school is 0.8. So, and if he stops for coffee, then the probability that he's late for school is 0.4. Otherwise means if he does not stop for coffee, means let us say we all know that probability of any complement event is 1 minus probability of that event. So probability that he stops for coffee is 0.8 means, let us say A is the event that he stops for coffee. So probability that he doesn't stop for coffee is the A complement is given by 1 minus probability of that happening, which is 0.2. 0.2. Therefore, probability that he does not stop for coffee is 0.2. Now, total there are two cases. He can be late to the school in two ways. One, if he stops for the coffee. Two, if he does not stop for coffee. Let's try the total probability now. Probability that he is late to the school is equal to case 1. He stops for coffee. This is conditional probability, guys, everyone. He stops for coffee is 0.8. Provided he stops for coffee, then the probability that he is late for school is 0.4. Plus second case, probability that he is not late for is not stopping for coffee is 0.2. We calculated here. If he is not stopping for coffee, then the probability that he is late is 0.1. Again, conditional probability. Here, why we are multiplying? The conditional probability says that the probability that the one event happened, after that the second event is happening. In that case, we multiply them together. So probability that he stops for coffee is 0.8 multiplied by he is late if he stops for coffee 0.4 plus probability that he does not stop for coffee multiplied by he is late if he is not stopping for coffee. Let's calculate that. This is 0.32 and this is 0.02, which is 0.34 total. That is probability that he is late. Now, this question belongs to Bayes' theorem actually. So in Bayes' theorem actually there are two things. Probability of required thing, whatever that, is equal to, in the denominator we write all the cases, whatever the number of cases. In this context only two cases are there. This will come in the denominator, this 0.34, the two cases. If he stops for coffee, what is the probability that he is late to the school? And if he is not stopping for coffee, what is the probability he is late to the school? Both cases are added together. I got 0.34. Therefore, this will come here. So what will be in the numerator then? Out of all these cases, one case or combination of cases will go to the numerator depending on what is being asked. In this question, see this, it's clearly given that on a particular day, Suresh is late for school. What is the probability that he did not stop for coffee? They want this part to be true for that particular day. He is late, but he did not stop for coffee. So this part should go to the numerator 0.02. Okay. So therefore here, this part is needed. So I'll mention that again, since we're going to use that. I'm going to call it as P of, we can call it as P of is late and did not stop for coffee. Did not stop for coffee. There are two cases, no? He is late and stopped for coffee is this. This is he is late and did not stop for coffee. We want this part, which is, again, I write the same thing, which is nothing but 0.02. Therefore, now the final answer, I can write probability that it's already given that he is late. Probability that he is late. But what is that? Did not stop for coffee. Did not stop for coffee. This is the Bayes theorem we are using. So we want the probability that he is late but did not stop for coffee is equal to what? In the denominator, total probability, which is 0.34. In the numerator, we get the total probability. I mean the required probability, which is, in this case, we want this 0.02, which simply simplifies to be 2 upon 34, which in turn can be written as 1 upon 70. That is the final answer. Okay. So let me summarize this one more time. Any Bayes theorem question generally has multiple cases. The probability in each case is added together. That is called the total probability, which will come in the denominator. Out of all those cases, because of which case this particular thing happened, that case will go to the numerator. That's the idea. Hope it is clear for everyone. Now, let's move on to the next question. In this question, they're asking us to integrate this. They've given a definite integration and substitution is also given clearly. Let's start with that. I would like to name the integration first for ease of writing. Let I is equal to, I'm naming the given integral as I. 3 to 7, 5x square root of x minus 3 dx. So now they are already given the substitution. So use u is equal to x minus 3 substitution. If u is equal to x minus 3, which means that x is equal to adding 3 on both sides, it will become u plus 3 because we are going to convert the entire integration into u, including limits and everything. So first things first, I using the given substitution u is equal to x minus 3. Therefore, x is equal to u plus 3. Okay, we keep it aside and we'll use it later. Now, here differentiating with respect to x. Differentiating with respect to x. So what do you get? Du by dx is equal to x ka differentiation 1, 3 ka differentiation 0. Now, just take dx to the other side, I'll get du is equal to dx. Now, along with that, we can even, we have to even change the limits also, guys. See this? I'm changing the limits. New limits I'm calculating. New limits. So when x is equal to 3, lower limit is 3 here. So put it here. This is the substitution we are taking now. So when x is equal to 3, u is equal to 3 minus 3, guys, which is 0. When x is equal to 7, upper limit, then u is equal to same place I substitute 7 minus 3, which is 4. Therefore, now we converted everything into u. Now, how your question will change? See that now I is equal to integral. Lower limit is what now? 0. Upper limit is 4. So 0 to 4. Right? And 5 as it is times x. X is u plus 3. See here. U plus 3 times root of square root of x minus 3. But x minus 3 is u. Dx is du. So I can replace dx with du. One of the common mistake that can happen is you forget to change the limits. You use the same limits 3 to 7, which is wrong. The limits are for x. I'm converting the whole question into u. So we need to change the limits also into for u. Okay, making sense? Now Once we converted everything into u, let's continue and try to solve this one. Root u means u power 1 by 2 only. Everyone knows that. Square root is power 1 by 2. Now, I'm going to simplify this. Integral 0 to 4. 5 I'm keeping outside. This root u goes into the bracket. U times root u means u times u power 1 by 2, which is powers are added together. U raised to the power of 3 by 2. So I'll get u power 3 by 2 plus this 5 times 3, 15 times root u, which is u power 1 by 2, du. I've written two integrals separate. See that root u times u and 3 times root u. This 5 is also outside, 5u and 5 times 3, 15. Hope it's clear. Then continuing the calculation, 5 times integration of u power 3 by 2 is, we all know integral x power n is dx is x power n plus 1 upon n plus 1. Same story here. N is 3/2. Therefore, 5 times u raised to the power of 3 by 2 plus 1. So 5 by 2 over 5 by 2. So 5 times u power 3 by 2 plus 1 upon 3 by 2 plus 1, which is 5 by 2. Plus second one, 15 times u power 1/2, which is u power 1/2 plus 1, which is 3/2. So u power 3 by 2 upon 3 by 2. This whole thing, limits are 0 to 4. Now this is a simplification which you can do easily. 5 gets cancelled here. Here also, this is 3 by 2, sorry. So here 3 times 5, 15, 5 times 2, 10. Okay, so this will become 2 u power 5 by 2 and this will become 10 u power 3 by 2. Limits 0 to 4. Now simplify that. 2 times upper limit 4 means 4 raised to the power of 5 by 2 plus 10 times, I think, 1 second. Yeah, 2 times upper limit 4, 4 power 5 by 2, 10 times upper limit 4. So 4 raised to the power of 3 by 2 minus lower limit is 0. Anyway, everything is 0. Here 4 power 5 by 2 means square root of 4 is 2. 2 raised to the power of 5 is 32. Plus here 4 ka square root is 2. 2 cube is 8. 8 times 10, 80. So finally, this is 64 plus 80, which is 144. So I, the given integral value is finally is equal to 144. Hope it's clear. We started with the given substitution, but here the key is to convert everything into u, including dx. Dx is converted into du, and whole question wherever x is there converted into u, including the limits. Then we can easily solve the rest of the integral and substitute the limits and get the final answer. Okay. Yeah. Now let's start with question number 3. Here they say that z is a complex number which satisfies this equation. Then find the value of this particular expression. Okay. So let's start the solution by taking, let z is equal to, we know that generally complex number is written as x plus iy. Let's take z is equal to x plus iy, then z complement will be, g conjugate will be x minus iy. If any complex number is x plus iy, then its conjugate is x minus iy. Okay. Therefore, substitute these two values in this equation. So in place of z, it goes, in place of its conjugate, it goes here. Therefore, that implies we get 3 times x plus iy. In place of z, I put this minus 4 times in place of its complement, x minus iy conjugate is equal to 18 plus 21i. Therefore, comparing, first we need to simplify this further. 3 goes into the bracket, 3x plus 3yi, and 4 goes into the bracket, 4x plus 4yi is equal to 18 plus 12, 21i. Now next step, like terms together, all the x terms together, all the y terms, I terms and without I terms. So 3x and minus 4x is negative x, and y, 4 plus 3, 7. 7yi is equal to 18 plus 21i. So comparing on both sides, real part with real part, imaginary part with imaginary part. The real part will be x is equal to negative x rather is equal to 18, and the imaginary part 7y is equal to 21. Comparing the real with real, imaginary with imaginary, guys. Therefore, x is equal to negative 18 and y is equal to 3. We get these two values. Okay, but we are looking for z upon 3. First, write what is z. Z is equal to x plus iy. X plus iy means which is equal to negative 18 plus 3i. But we are looking for z by 3, z over 3, which is equal to 18 plus 3i upon 3, which divides both of them, negative 6 plus I. This is z by 3. Now they want the magnitude of this. So the magnitude of this, z over 3 magnitude is equal to, we know the formula, square root of x square plus y square. Here x square is negative 6 ka square, y is 1. I ka coefficient is 1. So 1 square, which is simply 36 plus 1, square root of 37. So it's a simple question only. First, we substitute the values of z and its conjugate in their respective places, then simplify and compare the real with real. If two complex numbers are equal, that's only because the real part is equal to real part and imaginary part is equal to imaginary part. We did that and we could find the z and then z over 3, then magnitude of that, under root of real part square plus imaginary part square. Okay. Now let's start with question number 4. Here two parts are there, which carry 2 and 4 marks each, maximum 6 marks. In first part, they're asking that, show that this particular expression 2x plus 1 linear expression is a factor for this polynomial f of x is equal to 2x cube, so and so. So for this cubic polynomial, we need to show that this 2x plus 1 is a factor for it. Okay. So there are a couple of ways to do it. One is we can use the factor theorem, which says that if p of x is divided by x minus a, then remainder is given by p of e. Means we literally equate this factor to 0, and whatever the value of x we get, we substitute in the function, in the polynomial, whatever the value we get, that is the remainder. I repeat, equate the given factor to 0, linear factor, and that value of x you substitute in the function. In this case, if I want to use that, it would be like this. So let 2x plus 1 equal to 0. That implies which is equal to x is equal to negative 1/2. Now p of means f of, in this case f of x function is, polynomial is f of x. So f of negative 1/2 I need to find. Whatever I get, that is my remainder. So f of negative 1/2 means in this polynomial, wherever x is there, you have to substitute 2 times negative 1/2 cube minus 13 times negative 1/2 square plus 17 times negative 1/2 plus 12. So we need to simplify that. So 2 times negative 1 by 8, negative 13 times 1/4, negative 17 by 2 plus 12. So let's see that. Further calculation. 2 means I think it is 1/4, negative 13 by 4. We can make the all denominators equal so that it's easy to calculate. I multiply this with 2 and 2, it will become 17 times 2, 34 by 4. And here I multiply by 4, 4 times 12, 48 by 4. Now we have a common denominator, it's easy to handle. So 4 is common, numerators are added together, negative 1, negative 30, negative 34. 30, 40, 44, 47, 48, exactly negative 48, positive 48. I'm getting 0. So by substituting that, it is becoming 0 means it's a factor for it. Given thing 2x plus 1 is a factor for this one actually. If it was not a factor, you would have got the actual remainder. Okay. So here I repeat, by dividing p of x by a linear polynomial, a linear factor, if we substitute a in that, if we get the remainder. So what remainder is 0 now. What is the meaning of remainder being 0? That's only possible if the given thing is a factor for it. Since it is a factor for it, it should divide it. Now we can use, this is, without this also we can do this directly with the long division, but I was just showing that we can use this also. Now try to divide this with this using long division, 2x plus 1. Now since it is a factor for it, we want to divide it with it. So 2x cubed, negative 13x squared, plus 17x plus 12. So if I want to simplify this further, I'll continue with we need 2x cube to start with, guys. 2x cube means we already have 2x. So we just need x square extra. X square times 2x. 2x cube, x square times 1 plus x square. So subtracting them, we're going to get minus 2x cube cancel, negative 14x square. So we need negative 14 means we have 7 here. We need negative 7x. 7x times 2x, negative 14x square. And 7 times this, negative 7x. Actually, we need to drop down this 17x here. So minus will become plus, this will become plus. So 14 cancel, 17 plus 7, 24x. And drop down 12. So clearly we can see that we need 12 here. 12 times 2 is 24. And 12 times 1 is 12 exactly. See that it's clearly cancelling out. So we get the remainder 0. Means the meaning of this is the factors for this is this times this. So I repeat, therefore given polynomial f of x can be written as 2x plus 1 times this quotient, x square minus 7x plus 12. Making sense? It's like this. If I'm dividing 12 with 4, for example. How do I divide 12? 4 times 3 is 12, which is 0. Means 12 is equal to 4 times 3 only. Na? The divisor multiplied by the quotient is equal to dividend. Same thing here. P of x, f of x is equal to this times this. But we need complete factorization. Because if we want to solve the inequality, I need all the factors. So let us say 2x plus 1. Second part. For the second part, I am continuing this. First part already done here. We showed that is equal to 0 means here you can declare. So f of negative 1/2 is equal to 0. Therefore, 2x plus 1 is a factor. Therefore, 2x plus 1 is a factor of f of x. That's done here. Second part here. So we got one factor, we got one quadratic, but we can easily factorize the quadratic x and x. We need product as 12 and sum as negative 7. 4 and 3 will work, I guess. Negative 3, negative 4, both negatives. Then only it will become positive 12 and negative 7. Yeah. Therefore, the factors would be, if I equate each factor to 0, from here I'll get x is equal to negative 1/2. Here I'll get 3. Here I'll get 4. Therefore, negative 1/2 comma 3 comma 4 are the factors for this. Okay. So now the last part of the question, I mean the second part only, but in that we're continuing that. So what are we doing here? We need to solve this inequality, means where this is greater than 0. I want the values of x for which this expression is positive. We can do that by checking the sign of each factor, means how the sign of this will change, which is called the sign scheme. So let us say we know the number line. On the number line, I'm going to mark all the factors, all the roots. So -1/2, very first one, then comes 3, then comes 4, in the order I put. Now the total number line is divided into 1, 2, 3, 4, 4 parts. Now I need to know that in each part, what happens to my expression. But that expression is now divided into factors. I cannot calculate the value of this expression every time to see whether it is positive or not. It's very time taking. That's why I split into 3 parts, which is very easy to see the sign of each factor and then multiply all the signs and get the final sign of that expression. See that if I take any value to the right of 4, anything in this region 4 to infinity, anything you can consider. Let us say I'm taking 5, 6, 7, anything. Let's say 6. If I put 6 here, just visualize that. 6 times 2, 12 plus 1, 13, positive. 6 minus 3, positive. 6 minus 4, positive. Every factor is going to be positive. The product of 3 positive numbers is also positive. So therefore, you get positive here. Okay. Now, next between 3 to 4, take 3.5. 3.5 times 2 plus positive. 3.5 minus 3, positive. 3.5 minus 4, negative. 2 positive and 1 negative, though this is negative. Next also you can check in the same fashion. You get alternate plus minus. Generally, if every factor is present only once like this, if any factor is present 2 times like squares and all involved, then you have to be careful. Sign may change or may not change like this alternatively. But if every factor is present only once, plus minus signs by default will be alternative only. But still you can check them, but I'm just saying. So plus minus. We want the expression to be what? Greater than 0. Therefore, the expression is positive here and here, 2 regions. What are they? When x is between -1/2 and 3, and when x is between either this or this, you can say actually, or both are two separate. No? So either this or this, or second one is 4 to infinity, means x greater than 4, you can say. So this is the final answer. Therefore, your given inequality is positive, that is greater than 0, when x is lying between -1/2 to 3 or greater than 4. In these 2 regions, your expression is greater than 0. That is positive. I hope it's clear. Let's move on to the next question. Question number 5. So in this question, given the functions f of x is equal to this and g of x is equal to this, 2 different functions are given, and they're asking us to find f of g ka inverse. First, we need to find the f of g, then we can find the inverse. So let's get started. F of g of x we want. So f of g of x means what? It is nothing but like this, f of g of x. So put g of x wherever x is there in f of x. This is f of x. Therefore, in these 2 places, x place, g of x will come. 2 minus g of x, which is g of x, 2 upon x minus 1 upon x plus 3. X is g of x again, 2 upon x minus 1 plus 3. That's it. So further simplification is needed. So if you take LCM and all, you will get 2 times x minus 1 minus 2 upon here 2 plus 3 times x minus 1. Both x minus 1 gets cancelled in the denominators. To get this, further simplification will give you 2x minus 4 upon here 3x minus 2 minus 1, sorry. X minus 1. This is the f of g of x. F of g of x. So f of g or f of g of x, whatever you call it. Now, generally, when you want to find the inverse, what do we do? What are the steps? We just generally start by calling the output as y. Y is equal to 2x minus 4 upon 3x minus 1 is your function. Start from here. First, we flip x and y. We interchange x and y. So x here, y here. X is replaced by y is replaced by x. So this is the step 1. Step 2, now solve for y. Solve for y. So I want to make y as the subject. So cross multiply. If nothing is there, 1 you can think. This goes here, this comes here. Okay. So which is nothing but x times 3y. 3xy minus x is equal to 2y minus 4. We are looking for y. So both y terms together. Therefore, this one come here. 3xy minus 2y is equal to x minus 4. Taking y common from this, 3x minus 2 is equal to x minus 4. Now dividing with 3x minus 2 on both sides, y is equal to x minus 4 upon 3x minus 2. Okay. So x minus 4 upon 3x minus 2. Now finally, what do we replace it with? See, the objective of finding the inverse means what? What does the inverse do? F of x, in f of x, x is the input and y is the output. In f inverse, y is the input and x is the output. To just flip x and y. That's what we have done. Y is a function of x, but we flipped x and y and expressed again y as a function of x. Means we did find the inverse now. So this itself is the inverse. We can replace this y as f of g ka inverse, which is equal to f of g inverse, which is equal to this x minus 4 upon 3x minus 2. That's it. This is your inverse function. Required inverse function. That's what they're expecting in the form of ax plus b upon cx plus d. So first here composite function f of g of x we found by substituting g of x in place of x in f of x. Then inverse, replace f of x with y, then flip x and y, then solve for y. That itself is the final answer. Hope it's clear. We'll continue with the rest of the questions in next video. Okay. That's it for now.